In this lesson, we're going to look at rationalising the denominator of a surd. First of all, before we do that, we'll have a wee look at multiplying by 1. Now this seems very simple, but it's important we look at this before we move on to rationalise the denominator of a surd. So clearly we can see multiplying by 1 doesn't affect anything. If you do 6 times 1, you end up with 6. If you do 10 times 1, you end up with 10. And the same, multiplying a fraction by 1, you end up with the same value. 4/5 times 1 equals 4/5. The value is not altered, it stays the same, and that's really important. So 1 can be written in a different variety of ways. 1 doesn't have to be written as 1, you can write it as 2 over 2, which is 1. If you look at this fraction here, 4/5 times 2 over 2 becomes 8 over 10, which is just an equivalent fraction, which will reduce back down to 4 over 5. You could multiply by 3 over 3, and you would still effectively be multiplying by 1, or 5 over 5, or 8 over 8. Any fraction with the same value in the top and the bottom is equivalent to 1. 1000 over 1000 is equal to 1. So we can do it with algebra as well. A over A is also equal to 1. So 4/5 times A over A gives you 4A in the top, 5A in the bottom. Divide top and bottom by A and you end up with 4 over 5 again. So multiplying even by A over A is the same as multiplying by 1. So let's look at rationalising the denominator. So it says here, it's good practice in maths to write fractions with rational denominators. Values in the bottom of the fraction as whole numbers, if you like, 1s, 4s, 3s, 2s, 6s, 8s. So if it's not rational, we have to be able to turn it into a rational number, i.e. it's good practice in maths to do this. So let's have a look at how to do that. Imagine a fraction looks like this, 5 over root 3. This is the first example, this is the second. We'll concentrate on the 5 over root 3 just now. Root 3 is irrational. We want to turn it into a whole number, or a rational number. So in order to do that, we need to multiply it by something. Now the easiest thing to multiply root 3 by, to turn it into a whole number, is root 3. If you multiply root 3 by root 3, you get root 9, which will square root down to 3. But we need to multiply the top by root 3 as well, because we don't want to affect the value of this 5 over root 3, we just want to change the form of it. So we need to multiply it by 1. So if you're multiplying the bottom by root 3, you need to do the same to the top. And just like we saw on the previous screen, we're not affecting the value of this fraction, we're just changing it. Changing the form of it. So if you do the top, 5 times root 3 gives 5 root 3, and the bottom, root 3 times root 3 is root 9, which is just 3. So looking at the next example, the easiest thing to change the bottom value into a whole number, or a rational number, we multiply by root 2, but we must do the same to the top, because we just want to multiply by 1. So the top's going to become 3 root 2, and the bottom is going to be root 2 times root 2, which is 4, root 4, sorry, which is just 2. So you can see a pattern starting to happen. Root 3 times root 3 is just 3, root 2 times root 2 is just 2, root 5 times root 5 is just 5, and so on. Sometimes you have to simplify as well, so we'll look at these two examples to see how to do that. So top and bottom must be multiplied by root 2, because there's root 2 in the bottom. This will give 8 root 2 in the top, and root 2 times root 2 is root 4, which just turns into 2. In this case, you can divide the 8 by the 2, and that becomes 4. So 4 root 2 is our final simplified answer. In the last example here, at the bottom, we have a root 5 in the bottom, so same idea, multiply the bottom by root 5 and the top by root 5. So the top is going to become 10 root 5, and the bottom, this time we've got 3 lots of root 5 times root 5, so do the root 5 times the root 5 first, and then times it by 3. So root 5 times root 5 is root 25, which is just 5. So this comes to 5, and then you times it by 3. So 3 times 5, that gives you 15. And then the 10 over the 15 will simplify down to 2 over 3 root 5. So the end value is 2 root 5 over 3, and you can see we've rationalised the denominator to 3.